Good evening, everyone, once again. We are going to start, and we are going to start with a very short presentation from our host, Scaleway, whom we thank very much for giving us this opportunity to be here. Yes, Emma.
Thank you. So welcome to Scaleway. We're super happy to have you here tonight for the meetup. Can everyone hear me? Okay. Too loud? So I'm just going to take 5 minutes of your time before everything begins to explain who Scaleway is and where you are. So Scaleway. Here's a bit of a global context to start off with. We are one of the world leaders in cloud infrastructures. More precisely, we're the 9th world leader of cloud infrastructures and the 2nd public cloud provider in France. In a bit of a more concrete context, does anyone know the group Iliad? Groupe Iliad? No, Free Mobile. Everyone knows Free Mobile. Free Mobile and Free is a brand of the Groupe Iliad, just like we are. Scaleway is actually the cloud provider brand of the Iliad group. So that's a bit more concrete for you. A bit of history. 2015, that's the year Scaleway was born. Scaleway is actually a spin-off of an older 20-year-old company called online.net. Does anyone know? Scaleway is a spin-off of Online, created by Arnaud de Birmingham, our current CEO, and his colleagues. It was a very quick and huge success, as it was the first company to provide cloud computing IaaS solutions per the hour, 2 cents per the hour. A very quick success, which led to international growth already in 2016 and 2017. We had many requests and demands, some of which we couldn't all answer. We were out of stock on some of our servers, for instance, and it led to Scaleway having to build a new data center in Amsterdam. We gained, thanks to all of this, a massive and very positive reputation worldwide from the new generation of developers. 2018, a turning point year for Scaleway. The 3 brands that enabled the activity of Scaleway merged and all came under the umbrella brand of Scaleway that you all know today. Scaleway, as you can see here, Iliad Data Center, and Online by Scaleway. It meant it was a year of massive recruitments. We went from a company with 50 employees to over 200 employees in only a year. It's also the year that we created La Maison, which is where you are today. We have 2 Maisons, one in Paris and one in Lille. It's our offices. It's an espace de vie, as they say in French, more than an office, where we have very comfortable spaces to work, flex office, flexi time, and loads of other amazing contexts and advantages. It's the year that Scaleway became the main and the only brand, the umbrella brand for all our 3 activities. 2019 is the year of Scaleway Elements, which is our cloud ecosystem. Our cloud ecosystem is composed of 6 bricks. I won't go into too much technical detail, but we have compute, which are our instances, storage, network to enable all the data to move around where it should be, IoT, Internet of Things, connected objects, and another subject I'm sure you're all familiar with, artificial intelligence. And then the last one, steering, which is kind of like the toolbox enabling all the bricks to work together to compose our cloud ecosystem. 2019 is also the year that our data centers were certified HDS, which means we can host health data. And as a personal victory, well, personal and teamwork victory, it was the year of our Scale Day and Night. Some of you were there. The first edition of our annual client events with over 1,300 participants, clients, partners, a day full of workshops and conferences, ending with a huge party to celebrate the 20th anniversary of our initial company, Online. It was an amazing day. To put it briefly, I might be repeating myself, but a few figures, 20 years of expertise via our historic company Online and its dedicated servers, Iliad Data Centers and our high-end data centers, which enabled us to practice our activity. We have 5 data centers in total, 4 in Paris and surrounding area and 1 in Amsterdam. And as I said, a huge international reputation with clients in over 150 countries worldwide. So it's pretty brief, but if you have any questions, feel free to come and ask at the end. Also, we host many events and many meetups. If you're interested, feel free to follow our 2 pages for the office in Paris and the office in Lille. You're always welcome to our meetups. We'd be more than happy to see you again. That's about it. Thank you for listening, and I hope you enjoy your evening, and we'll see you at the apéro.
Thank you very much. Thank you very much, Emma. It was very interesting. And thanks once again to Scaleway for organizing this event and hosting us. So let's move to our own slides. So once again, we're beginning, and it's our 23rd meetup, and we are hosted by Scaleway. And we are very, very happy to meet you. Just please let me know how many people here for the first time. Wow, that's impressive. You're very welcome to this meetup. You will see we're a pretty friendly bunch. And please don't hesitate to come and to talk to us, because the team consists of 4 people. My name is Anaëlle, and we have together today 2 of the co-founders, Caroline and Chloé. So please, once again, don't hesitate to ask questions, don't hesitate to speak to the speakers, and don't hesitate to speak to us. We are part of a global movement, Women in Machine Learning and Data Science, whose aim is to promote women that work in the field or are interested in the subjects. And we are very proud because the Paris chapter is the 3rd largest in the world. We count more than 3,000 members, and it's thanks to you, our members, that we are growing so fast and are so strong. Now, WMLDS has a code of conduct, and obviously you're going to respect it, and it's just here to remind how it is. Basically, we try to be kind to each other and don't insult people gratuitously. You can follow us on all social media. You know, we have more than 1,500 people following us on Twitter, almost 1,000 people following us on LinkedIn. We always publish resumes of our events on Medium. So if you want to get in touch, you can also send an email. So basically, we are everywhere. And we are going also to be featured in the first print magazine of Actu IA. It's going to be published at the end of January, so you can still order your copy online or wait until it will appear in the kiosks. And so we are the first meetup to appear in these magazines. They are a very good friend of us. And some of you in the audience are already experts for this media. It's a media that popularizes subjects of AI, data science, and machine learning. And if you are interested to become experts, please let us know. We'll put you in touch. We have another partnership coming this year. It's a Deep Tech Week organized by Hello Tomorrow. Our event will not going to be during this week because of the calendar, but you can follow them and to see what the deep tech ecosystem is doing. And obviously machine learning, data science, AI is very much part of it, but also there are all kinds of activities around biotech and aerospace and other areas. Another movement we are really supporting, it's the first mathematics Olympiad for women, basically intended for girls. And if you have daughters, cousins, sisters, friends who might be interested, they can still register. Another event, also mainly for girls, an event at UPEC, one of the Paris regional universities. Also, you can, if you have some friends, sisters, daughters, whatever, nieces, please come and tell them to attend. This is not for girls, it's already for PhD and postdocs. Deutsche Telekom announces a challenge for best thesis on data science and AI and machine learning. And we are going to publish all information on a Medium recap, but also you can find more information on our Twitter. Now, a call for speakers. And we, as you know, as a meetup, all our speakers are female speakers, although the meetup is mixed. And particularly, we like first-time speakers. We have already quite a large list of speakers who we are going to feature. But if you never spoke in public, or if you're French and never spoke in public in English, our meetup is a perfect place to do it. And we are very friendly to our speakers. And if you want to speak, please come to talk to me directly. And if you want to know what is the experience for a first-time speaker at our meetup, you can speak to the lady on the picture. Victoria, raise your hand. She spoke at our meetup last summer, and we were extremely happy about her magnificent talk. So think about it. Think about this year making a speech at our meetup. Now, today, it's still a sort of New Year season. We are going to have a book raffle. You all have small numbers in that were given to you during the registration. And at the end of the meetup, just before the cocktail, we are going to do a random number generation, and some of you will receive a book. Now, we have another announcement today, and I'm going to give the floor to Isabelle Hilali, whom some of you know. She worked in CRI for many years, and she just started a new company called DataCraft, and they're organizing very interesting challenges around data and sport. Isabelle, please.
Thank you so much for inviting me. Hi, everybody. So very quickly, DataCraft, it's a club for data scientists. And the idea is a bit like the meetup to make sure that data scientists can gather and learn from each other. So really the idea was to find a way for data scientists to train amongst peers. And we are opening, it will be a network of places. We are opening the first place in Paris at the end of the month, and then there will be other places worldwide. And maybe I have two announcements I wanted to share. One, the first one is that February 6 and 7, we are organizing together with INSEP. INSEP, it's the high-level sport in France. So on their data, we are organizing 2 days of workshop to train on their data. And really, the idea is it's not a hackathon. So the idea is not to spend 2 days together and find a solution to who is going to be the next champion in rugby, for example. But really, the idea is to see if we spend 2 days together, what do we learn from each other? And when we leave those 2 days, are we more committed to our own projects? And do we really feel that this is really very exciting to be working together? So that's really the purpose of the workshop. So if we will work on rugby and aviron, so I don't know how to say aviron. Rolling, yes, sorry. But again, that's just, we could work on any other kind of data. And the people in the room will be people from startups, from sport, from large companies, from public research, like people from scikit-learn who will share how we can use their libraries. So really it's a whole group of people. So if you want to know more, just contact me. And the second announcement is that the way DataCraft works, it's subscriptions from companies that allow data scientists to join the club. But for people who do research or for people who are in freelance, we will have residencies, like in arts, you have residencies. We will have residencies for data scientists, and we will make calls, but you can apply and you can come in residence. And what we ask in exchange is that you give a bit of your time and your expertise to the community. So that's the principle. So, well, I forgot to put my email address, but it will be in the minutes, and you can contact me if you like. Thank you.
Thank you very much, Isabel. So we'll put her contact details in our Medium recap, but also she's staying here. And if you're interested in this topic, please come to talk to her directly. Now, our next event is a paper study session, which something we launched last year, and it's our, I don't know, what is our fourth event or our third fourth. It's our fourth session, and it happens during lunchtime at Agorize, and it's kind of people come, read together a scientific paper and discuss it. So please, if you're interested, details are already on our meetup page. And now let's go to tonight's agenda. So it's our usual format. We have 2 technical talks, and then we have a talk more general on the topic of science and innovation. And then we are going to have a book raffle and networking cocktail. Let's start. And I would invite our first speaker, Olga Petrova, who is machine learning engineer here at Scaleway. We met actually with Olga during the Scale Day last year, and we immediately said that you should come to speak, and she immediately agreed. So it probably was the fastest speaker recruitment in the history of our meetup. And what is very interesting, Olga has a PhD in physics, and like many people of our community, she successfully moved careers from academia, physics to machine learning in industry. And you also can talk about this topic to her. So Olga, I'm giving the floor to you.
So the topic of today's talk is semi-supervised learning with GANs, but I also have a second title for it. And the second title is what happens when dogs and cats are left unsupervised. So first I will start with the outline of my talk. There are 2 parts. The first part is rather theoretical. So there I will explain what is semi-supervised learning, what are GANs. GAN stands for Generative Adversarial Network. It's a type of algorithm that I will describe. And then we'll explain, well, how do the 2 fit together and why should we care, basically. And then finally, the second part is the part where the cats and dogs come in. So semi-supervised learning. To start with, there's unsupervised machine learning. That is when you have, you also have data, right? So you have data that is unlabeled and you train on that. And some examples of algorithms that you can use are, for instance, clustering or GANs, generative adversarial networks. Originally, they were meant for unsupervised learning. Then this can be contrasted with supervised machine learning when, in addition to data, you also have, labels. So each training sample comes with a label or a target. Some examples of tasks there include regression or, for instance, image classification. And finally, semi-supervised learning is a bit of a mix between the 2 because you have a subset of your training data that is labeled, and then the rest of the data is unlabeled. And the tasks that you are concerned with are generally still of the supervised learning variety. So that's what it is. Now, why should we care? As many of you probably know, the recent breakthroughs in deep learning in particular come at the expense of introducing very large models. So deep learning refers to deep neural networks. So the deeper the network or the greater the number of trainable parameters, the more data you typically need for training. So many of the more practical applications are actually of the supervised learning variety. So this data has to be labeled. However, it is expensive and time-consuming to label your data. So unlabeled data, which is much easier to collect, basically it's advantageous to be able to use this unlabeled data in order to boost the performance of otherwise supervised learning models. Now, generative adversarial networks, or GANs. So this part is going to be a little bit more technical. So as I mentioned, originally GANs, which were introduced in 2014 in this paper by Ian Goodfellow and company, originally they were meant for unsupervised learning. So your training data is, let's say, MNIST images. So MNIST it's a well-known data set with images of handwritten digits. So in general, they are labeled. Zeros, ones, etc. But let's say you take all of these images and they're not labeled. So you can use that for training. And the goal is going to generate data that comes from the same distribution. So in this example, you would want to generate images that look like MNIST images. So here I just have a little image with what the training set looks like. There are two networks here. The first one is called the generator. Now, the way that the generator works is that you have input vectors that are just random noise. And then once you pass them through the generator, what comes out is some image that I refer to as fake, just to stress the fact that it's a generated image. Now, there's also a second network that is called the discriminator. The discriminator is going to take two kinds of inputs. One kind are the real inputs that come from the training set. And then the other kind is these generated images from the generator. Now, the discriminator is actually nothing more than just a binary classifier. And here we just train it in a supervised way. We're going to say that the images from the training set are real and the images coming from the generator are fake. So the way that the training actually works here, as I said, for the discriminator, it is fairly straightforward. For the generator, it is a little bit more tricky. So these images that have been generated by the generator, of course, they depend on the parameters of the generator's network. So once we pass those images through the discriminator, let's say that we got them assigned to the false category. What we want to do for the generator is to adjust the parameters so that the next image that it is going to generate will be closer to the real thing, which will hopefully be accepted by the discriminator. So in a way, the goal of the generator is to fool the discriminator, and you train the two at the same time. So I have a short piece of code here, which of course I don't expect you to read. This is just to give you an idea of how the training would work in practice. So in practice here, you would take a batch of real images coming from the training set. And then basically in the first part, you would pass this real batch to the discriminator and say that this is real, accept it as real. Then you would create a vector of random noise, pass it through the generator, create a batch of generated images. And then you pass that to the discriminator and say that this is supposed to be fake. And then you just update your discriminator for the batch. For the same batch, you are next going to train the generator. For the generator, you're going to say that you want to have that batch of generated images to be accepted by the discriminator as real. So as you can see, there are two conflicting objectives for the two networks, and you just train them like this alternatively for every batch. Now in this slide, I wanted to give a bit more of a mathematical look at what I just talked about. So if it doesn't help you, don't worry about it. There's no really new information here in addition to what I just talked about, but it might help you. So we're going to say that the real data comes from some data distribution, and then of course the generated data also comes from some data distribution. And what we want to have in the end is to have the generated distribution be close enough to the real one. Then the objective for the discriminator is, well, it's easy. It's just to assign the correct label, what's real and what's fake, or what comes from the training set and what is synthetic, what has been generated. And the generator is trained to produce images that fool the discriminator. So actually, if you look at the this expression here, this might look familiar to you if you have done, well, classification before. So actually for the discriminator, this is just a regular expression where you want to assign, well, ones to what comes from the real distribution and then zeros to what comes from the generated distribution. And what you do for the generator is actually the opposite of that. So if this didn't help you, don't worry about it. It's basically what I just talked about on the previous slides. Okay, now moving on to semi-supervised learning with GANs. So here we'll start with a basic idea, and the basic idea, well, uses this fact that there's data with a certain distribution, hence the previous slide. So our training data has a certain distribution, and then during the training of a GAN, the GAN would attempt to learn that distribution in order to produce samples from it. So then the basic idea here is that you are doing this sort of clustering, because, for instance, if you are working with a MNIST data set, you're going to have kind of 10 nodes in your distribution, let's say, and then the GAN will hopefully learn that. And the presence of your labeled samples is going to help the model to assign a particular label to each cluster, so to say. So I'm going to use this very simple example here to illustrate the idea. So let's say that we have data that only has two features. And well, if data only has two features, we can say that they are an x coordinate and a y coordinate. And then we can just plot them on a plane. So our data comes in the form of two circles, and the two circles correspond to two classes. So this is easy enough, of course, unless we don't have that much labeled data. So let's say that all of this data of the two circles is unlabeled, except for just a few points here. Now, if we want to do our regular supervised machine learning, we're kind of in trouble because, well, from just looking at these points, you can't really tell that there are two circles with two classes. However, if you train a GAN on this, all this unlabeled data, the GAN will easily learn that your data comes in the form of two circles. And then you can also use the fact that parts of the circles are labeled to say that they actually belong to two different classes. So that's this basic idea behind the semi-supervised learning. Now, one of the ways in which this can actually work in practice, well, can be the following. So for an unsupervised GAN, as I said, there's a generator and a discriminator. And you might recall that the discriminator is actually a classifier. And let's say that what we are trying to do, the supervised problem that we are trying to do, is actually classification as well. And supervised classifier would classify into k classes. So for MNIST, your k would be equal to 10, because there is a total of 10 digits. We're going to replace this classifier into k classes with a classifier into k+1 classes and say that this additional class that we created corresponds to fake images. So that should hopefully sound familiar. So the first k classes are real, the added one is fake, and then we proceed with a semi-supervised GAN. In a similar manner, we still have the generator, just like before, and we now have a new discriminator / classifier. Now, the training is going to be a bit different because before we only had two types of data. We had real data and we had generated data. Now we have three types because the real data from the training set can be separated into two categories. We have labeled data and also unlabeled data. So the discriminator now has three different objectives. For the labeled data, it wants to assign it to correct classes. For the unlabeled data, it wants to assign it to one of the k classes. It doesn't know which one because it is unlabeled, but that is the objective. Now, the generated data should be assigned to the fake class, the one that we added artificially. And finally, the generator, of course, wants to produce images that look real, but are unlabeled, so they should be assigned to one of the k real classes. Now, one of the questions that I had about this when I was first reading about the semi-supervised learning with GANs was how good are the resulting generators? Are they as impressive as some of the unsupervised GANs that I've seen? So you might be familiar with a website that's called This Person Doesn't Exist. So you click on it, you get pictures of people that actually don't exist, that have been imagined by an artificial neural network, which is actually a GAN. So that's one example, and they do look pretty realistic. Now, there was a paper that I read that is referred here, and the title of the paper is Good Semi-Supervised Learning That Requires a Bad GAN. So as you can guess from the title, perhaps, actually, in order to get a good classifier, you have to have a pretty bad generator. I will have an example of some images that I have generated while, well, while getting pretty good classifiers. So there is a reason for this. So actually, to get a good classifier, the generator has to be complement in a way. And by complement, I mean that it generates samples that are complementary to the real ones in feature space. So if we go back to my favorite example of two circles, so if you look at this unlabeled data, it's pretty clear that there are two circles. So if you had a, well, let's say good generator, this would just mean that we would generate more and more points for the two circles, which honestly wouldn't help us very much. However, if we start generating points in between the two circles, this is going to help us in the following way. So the model will quickly learn that they're fake because, well, it looks at the real data and sees that there isn't any in between. So it will learn to classify them as fake, and then it will also see that whatever is on the inside of this fake ring is, well, one class, the blues, and whatever is outside is the other class, like the oranges. So basically generating fake points that are complementary to real data leads to a better decision boundary between classes. So in this way, it takes a bad generator to accomplish, good classification. So actually, I should mention that there's a big difference between our objectives when we're doing unsupervised learning with GANs and semi-supervised learning with GANs. Because in unsupervised learning, what we want to have in the end is a generator because we're interested in it generating data. Here, we are not really interested in what the generator is outputting. We're just using it to train our classifier. So here, the final product is going to be the discriminator, because that is our classifier for the real data. So I'm going to skip the slide. Maybe we'll come back to it in the end. And these are some of the improvements that can be done in this basic generator plus classifier architecture. Okay, so now we get to the practical part. And I always try to find a way to work pictures of my pets into a presentation. So here it was easy. Because I happen to have both a cat and a dog. So there they are. And of course, every tale should come with a moral. Normally, the moral comes at the end of the story. Here, it makes more sense to start with the moral. So the moral of this tale was actually to read the fine print. And what I mean by that is to carefully read papers when you attempt to implement them. So when I started reading these papers on semi-supervised learning with GANs, I decided to try implementing something kind of simple, but a bit more sophisticated than MNIST classification, because after all, most real data doesn't come in the form of 28 by 28 pixel black and white images. So I decided to do dog versus cat binary classification. Now, by option one, I mean the first thing that I tried to do. Basically, I read about these ideas of, adding an extra class in the classifier, treating that as your fake images, and decided to just sit down and just write it up in PyTorch. And sounds easy enough. So in this case, k is equal to 2. There are dogs and cats. I'm going to add a third fake class. So in other words, my classifier is going to have 3 logits, three final outputs. In the network, the unlabeled data should be, well, the discriminator should reject it. No, sorry, the discriminator should accept the unlabeled data because that is the real data. So it wants to minimize the probability of the third class for that data. Now, for the generated data, the discriminator wants the opposite. It wants to minimize the probability of that data being assigned to cats or dogs classes, whereas the generator, well, for the generator, we want to do the opposite. So this was really easy enough to do because for all these probabilities, you take the softmax of the final layer, you add it up here, you take the mean. Really, that's it. It all sounded very easy. And it really didn't work. I tried to get it to work for a couple of weeks, actually. And by not getting it to work, I mean that there was no improvement whatsoever over the baseline, whereas my baseline is just doing supervised learning on a limited number of samples. So this was confusing and also frustrating. So I went back to reading the paper. So the first paper I read was this one, the Improved Techniques for Training GANs. From 2016. there was a single sentence that said that the classifier with k+1 classes is actually over-parameterized. And they didn't make it, it didn't sound like a big deal to me at the time, but then they gave this impression that can be used for the loss function for the discriminator. And basically what happens here is that even though you keep in mind that there are k+1 classes for the discriminator, you don't actually add the k+1's class. You keep the dimensionality the same. But then because you change the loss function, you are going to have this expression here where it will give basically a 1 if you have a strong class prediction for one of the classes, in this case, a dog or a cat. So if you're quite sure it's a dog or quite sure it's a cat, it will be a 1. However, if you don't really know, you have small class predictions for both of them, it will return something close to a 0. So in that way, it is kind of like a softmax layer for the k+1 classes in a way, because if it was just a softmax layer, the results would have to adapt to 1. So you would have to decide one way or another. You would have to decide whether it's a cat or a dog. This gives you another option. This is an option to say, I don't know. And I don't know basically equals to the image being fake. So I just did this one small change. And then miraculously, everything worked right away. So speaking of everything working, let's go to my GitHub repository. Okay, we'll just have to stay here by the laptop for a bit. So basically, I implemented this very simple semi-supervised GAN in PyTorch. It was just using a classifier, classifying into 2 classes and a generator. So I will show you the code briefly. I have the link in my slides if you want to look at it later. But there are a couple of things I wanted to mention. The first one is, I think, something that is useful for anyone doing computer vision. So here I had to resize my images to fit to the network. So the size that I used was 224 by 224. And the thing is that when you resize images on the CPU, of course, it takes a really long time. So I used this DALI library that I use every single time I do computer vision. That does all of the pre-processing, so resizing, cropping, any kind of transformation, normalization, etc., on the GPU. So it is something that I just recommend. Then I wanted to show you a few examples from the data set. So to me, it is quite realistic, quite a bit more realistic than MNIST at least, because there's large variety between cats and dogs. Also, all the pictures come from different environments. Some of them are inside, some of them are outside. Some of them also have multiple animals on them. Some of them also have humans. So it's not the most trivial set, actually, which was nice. Well, plus there's the added bonus of actually looking at the pictures of dogs and cats at work. Then I took a ResNet 18 model just to pick something fairly standard, and I trained a supervised model on 100 training samples. So I start with a model that has not been pre-trained, of course, because otherwise you get something very close to 100%, since dogs and cats are one of the classes. Okay, so our supervised model achieves 60%, which is more than I expected, actually, on just 100 images, 50 cats and 50 dogs. And then I have a semi-supervised GAN. Again, I won't dwell on the code too much, but basically I have a generator that is a deconvolutional neural network. They're just a bunch of convolution transpose layers producing an image in the end. And my discriminator is still a ResNet 18 classifier. So here, I didn't train it for very long, but just to show you that after 13 epochs, we got a 12% improvement on the accuracy already. And another thing I wanted to show you was, remember when I talked about a bad generator, how the generator is not going to be that great? I want to show you the image that was generated after 13 epochs. So just to put it into perspective, it's something that gives us a significant improvement in accuracy, from 60 to 72%. However, the images that it generates don't really look like much. Yes, they're a little bit creepy because you can see cat's ears quite often, actually. Some of them look like almost dismembered animals. So yeah, I apologize for that. But basically, right, the generator is going to be quite useless. We should throw it away. But the classifier is not bad. And now just kind of back to the results. Something else about this is that, of course, when you don't have many labeled samples, your results are going to depend very strongly on the choice of the labeled samples that you make. So for my first 100 of images, first I chose them randomly, then I looked through them quickly, and I did replace a few of them with others. So basically here I removed the images that had humans on them, removed images that had multiple animals on them, or the ones that had too many occlusions. So I only kept the ones where, for me, it was very easy to tell, is it a cat or is it a dog? Because with some images, it's actually not so trivial. Like a lot of those Pomeranians could go either way. So basically, on this set that I almost handpicked, that's where the performance was best. It went from 60% to 83% in accuracy. So 23% improvement after 40 epochs. But because I know that, of course, it is going to depend on the choice of the 100 images, I reran the whole thing twice more on just randomly chosen images. Again, 50 cats, 50 dogs. Here, the improvement was closer to 10%. So it does vary. I should say that it is very likely that it's possible to get bigger improvements, because actually I didn't play around with the hyperparameters that much. So these were just the first ones that worked. So yes, with that, I guess I will just give the take-home message of why should we care about this semi-supervised learning with GANs. So basically, if you are trying to do something like image classification and you don't have a huge number of labeled images, there are two ways for you to go. You can either pay someone to label your images, which in some cases is going to be, of course, more complicated than others. Like, for instance, if you're dealing with medical data, you might have to employ a medical doctor to sit down, just look through thousands of images and label them, which takes a while. Or another thing you can do is possibly get away with a smaller amount of labeled data and just invest into a development of a semi-supervised model. So there are trade-offs between the two, but you have options. So thank you very much for your attention.
Thank you so much, Olga. It was very clear, very pedagogical presentation. We have time for a few questions. So please, if you have any questions for Olga, raise your hand. Yes, great. So there's a microphone circulating.
You said that in order to get a good discriminator, you need a bad generator.
Mm-hmm.
Can you please explain once again? I didn't get it.
Sure. So actually, when I first read about it in the paper, it wasn't clear to me either, because it said it should be a complement generator. So what it means by complement, the best example that I found was this two-circle dataset. Oops. So, okay. Basically, here our feature space is very easy because it's two-dimensional. So the real data comes in two circles. What is complement would be whatever is outside the two circles. So a bad generator would be the one that wouldn't generate something similar to the real data. It would be the one that would generate what is not. Or in this case, what is not inside the two circles. So this is what gives you clear decision boundaries between classes, because in the end, this is going to be something in between classes. The network will learn where those boundaries are. So,
to recognize the fakes that look like fakes, and if you have a fake but which is in the boundary, it will be more difficult. So isn't that a problem, that your generator generate really fake images that do not look like real?
Well, so actually, I mean, here, this is something that's bad about this example, because so there's fake and then there's fake, right? With cats and dogs, the images that it generated, it didn't generate just noise. They weren't completely featureless. However, they didn't look like cats or dogs. So, well, it's hard for me to mention the feature space for a cat, but let's say the feature space included like a tail, whiskers, and ears. So in the end, you want to generate something that would have the same types of features, but wouldn't have the ones that correspond to a cat. So they should look like images in the end, just not the ones that correspond to the to your unlabeled data.
Thank you very much once again, Olga. And obviously, you can ask your questions after the official part of the speaking part of the meetup is over. And now we are going to present our second speaker, who is Anaëlle Laurans, who is machine learning engineer, and she's going to take us to the fascinating world of gaming. Please, Anaëlle.
Okay, thank you. Hello, everyone. I'm Anaëlle, and I'm working at Samsung AI Labs, but I'm here today to present my interest for AI in games. So I will answer the question, why is it important to solve games with AI? And it's an interesting question because we can think that solving the game of Go or a Rubik's Cube can be a futile project, but I will see that we have some benefit to do that. So just to avoid confusion, it will be not about AI that designed for game purpose, I mean game design purpose. I will mentioning more about the research side of game AI. And so I will obviously answer the question, why is it important to solve a game with AI? And also some machine learning method and some changing that remain unsolved. So let's start with a bit of history. Before artificial intelligence was a field, early pioneer in computer science wrote game-playing program to test if a computer can solve a task that require intelligence. So in 1952, Douglas wrote a program that mastered the game of tic-tac-toe during his thesis. In 1959, Samuel created a self-learning program to play checker, and that inspired today what we call reinforcement learning. So we see something here that games are designed to change the human brains, and since they change the human brains, they are perfect to test our capacity to develop better AI. And games can be really challenging for a computer. So to measure our progress in AI, we can compute a game through the space game, this game complexity, which are the number of available states a game can offer. Here an example with the tic-tac-toe game. So we have 3 values, XO and empty, 9 spaces where we can put these values. And when we compute the complexity of the game, we arrive to more than 10,000 possible states. If you continue, chess are more than approximately 10 power 47 possible states. The game of Go, 10 power 170 possible states. StarCraft 2 is too big to read. And for comparison, the number of protons in the universe is about 10 power 80. And yet, we saw the game of Go and StarCraft. So games can be really milestone about on our progress to make better AI. We arrive to a second reason, games are rich human-computer interaction. Think about multiplayer games where players have to cooperate or compete with other players. So when we're designing bots that solve a game, we are also teaching the bot to play with AI. With bot playing with humans. I took this example from the OpenAI blog. They created a bot that can play Dota 2. So in Dota 2, you play in a team with 5 players, and you have to cooperate to take the opponent base. So they did this experiment where they put 3 bots and 2 players in the same team. And what is interesting is the quote from the human that they were feeling supported by their bot and learn from them. So it's really interesting because it's promising for more advanced interaction with our computer. Next, we have since the games have a lot from the nature of the game. When we are designing bot that solve AI, we have to deal with multimodal inputs and multimodal outputs through spatial temporal context. So in research, research for games can be really useful for other AI domains. For example, from the AI perspective, when designing a bot, we have to deal with diverse nature of observation, like images, text, sound, vector, etc., to fusion them with the temporal context in mind, and to output diverse action like gesture, key press combination, pointer, etc., text, etc. So here again, it's very interesting because the AI, this domain touches several core domains in AI, like computer vision, text, signal processing, and the scientists have to tackle the notion of behavior and planning with this temporal context in mind. So this is very challenging, and it can help other AI domains. So now that we have seen several reasons, I will show you some way used to resolve that. So I cannot talk about all the methods that are used, but you should know that the winning solution are using reinforcement learning. Reinforcement learning is a framework where you have an agent that learn through interaction with an environment. So, for example, when we play a game, we are doing the same thing. We are seeing the observation, we are seeing the game, we are trying something, an action like jumping, like going forward, and we have feedback through the score that we obtain from the game. And we are doing again and again through trial and error until we win the game. So this is the same thing, same framework here. What's the part that the most interesting is how we design an agent to take the decision. And here I have an example. From the DeepMind. In DeepMind, they released a paper in 2015 that used deep learning and reinforcement learning. So for Atari game is like Pong, Tetris. So it's very old games used for tackle this problem. But in this settings, they use several images, feed a neural network to output values for each available actions. So they take the marks for the decision, but in this paper, they bring a lot of contribution and a lot of way to use deep learning to scale reinforcement learning in more complex game. Please note something here is that the optimization is very different from supervised learning, because once you optimize your network, you use it right after and optimize it again. So it's very different from supervised learning. But it can be, there are some inspiration in the optimization. There are a lot of approaches in games and in reinforcement learning. as you see in this landscape. For example, the game of Go, they use Monte Carlo tree search. Here, Monte Carlo tree search, which is they combine that with deep learning and reinforcement learning, obviously. And Monte Carlo tree search is just a way to heuristic to search in a tree to overthinking what the opponent can be play. For the game, for Dota 2, they use a policy gradient method, proximal policy optimization that can found in this landscape here, which is quite different, and I don't have time to explain here. For StarCraft 2, they use imitation learning, which is a combination with supervised learning, reinforcement learning, and deep learning, where they use data from players to optimize, in fact, to improve the speed learning of the agent. And there are a lot of applications outside games from reinforcement learning. For example, they can be used in natural architecture search, in resource management, in animation, finance. So if in paper you see the researchers are using deep Q learning, you can think about how it was found, because it was found on learning on Atari games. So it's very interesting how to see how algorithms found on games can be used outside the game domain. Just a word on my work, on my free time. So there are challenges on reinforcement learning because the agent learned is good at one game, but so I'm trying to tackle the problem of generalization and skill transfer. Skill transfer is about when you have learned to play, for example, soccer game, and we give you another soccer game. Now you are able to play well the game because we have learned on one game, you can transfer the skill on the other game. So this is skill transfer, and I'm working on that with the OpenAI environment. They released recently an OpenAI environment that use procedural generated level. That means randomly level generated randomly, and so even if researchers found a solution to this problem, I found always exciting to be able to tackle the problem on my own. So this is one of the problems I want to tackle in the next month. Also, to be able to do reinforcement learning at home, I have to improve my workflow. That means better visualization. Here I have an example of my visualization. The first one was using Bokeh. Bokeh is a Python library where you can plot data and get a web page. So I asked the web page to get this visualization, but as you see, it is not really human readable. I have images, I have all the value in turn of my agent. I can play with the time step, but he missed something. So I redesigned it to use a interface, human interface classical. And yeah, it's better, but still I want to improve way more my visualization tool and workflow. Just take home message. Games are really great to work with interaction and behavior, with multimodal inputs and outputs to deal with all the kind of nature of information is very interesting. and also to design bots with, that can play with humans. Finally, algorithm development in games can be used in other AI domains. I thank you for your attention for this presentation.
Thank you so much once again, and obviously you can continue this discussion after the talks. And now we are moving to our third talk, our famous third part. As you know, our meetups always have 2 technical talks and 1 talk on the general topic of women, technology, science, society, innovation. And today we are extremely happy to have a very special guest, Louisa Zanoun, who is a senior Science and Innovation Officer at the British Embassy. And she's going, this is a world far away from majority of us, and we are completely fascinated and very grateful that she accepted to give this talk, and she's going to talk about her work. Thank you so much, Louisa, and please, the floor is yours.
The one on the right. Okay, thank you. Right, good evening. I have to say I am very honored, but also very humbled. I'm not a data scientist, I'm not an engineer. I'm a social scientist by trade, but I'm very happy to be here, so thank you for having me. So my name is Louisa, and I work in the British Embassy here in Paris, very close to here. And I will explain, so I'm not a data scientist or an engineer, but we do work with scientists all the time. And I'm particularly happy to be here because I hope we'll be working with your association later in the year. So just briefly, so I'll introduce myself. So I'm a French national. I was born in France, but I lived in the UK for a long time, in London in particular. So I left France a long time ago, spent about 14 years in London. I did my PhD there at the London School of Economics. With LSE, they don't do data science. No, pure science anyway. And then I have what we call an interesting background, which the French call atypique, but in the UK it's completely normal, or normal. So I left after a master's in history in the UK as an Erasmus student. I worked in the City of London in the financial sector, in the tech sector at the time. Started my career when Google was created in 1998, so a while ago. So I worked in the tech sector in London, financial services, for about 8 years. And then I got really bored. I was well paid, but bored. So I went back to university and I went to LSE to do a PhD in international history. So the history of international relations, politics. And then what did I do? So I started teaching at LSE, a few universities. I did teaching and research in history for a few years. I got bored again. And it's actually very important. It's the question of impact. What sort of impact we have as professionals in our careers? What are we trying to, leave behind us? And it's very important because the Foreign Office is obsessed with impact. I left and I worked actually for an NGO here in Paris for 4 years, working as the head of research, working in culture and heritage, basically helping migrants here in Paris. And I left. I joined the Foreign Office in February 2017, just 6 months after the Brexit referendum, which I know you all know about, and I won't talk about just here, but I can talk about it later by the bar. I have to say, I will keep this very brief because I'm the one person between you and what's waiting there in the bar. But just very briefly, I will talk about the UK Science and Innovation Network, what it is, our objectives, what we do, why the UK Foreign Office has a science and innovation team, and then I'll give you examples of activities and impactful achievements we've done. So we called SIN, Science and Innovation Network. We're a global network, and you have a map here. There's about 110 of us across the, is this working? Across the globe. We work in embassies, consulates, and what we call missions. We're funded mainly by the Foreign and Commonwealth Office, so we're very much diplomats. That's what we do. We promote science through the diplomatic channels. And we're also funded by the Department for Business, Energy and Industrial Strategy. Interesting to know that in the UK, research sits with the business department. Higher education is with Department for Education. Research and innovation are considered elements of, how can I say, they contribute to economic growth and job creation. And so we sit with the business department. So our main job as science attachés across the world is to present to our host countries what the UK is doing in terms of research and innovation. And also we're here to identify and build partnerships and cooperation. Government level, so we talk to people across French government, from the Élysée, Matignon, Research Ministry, Bercy, who else? Ministry of Health, but also institutional level. So research organizations, CNRS, INRIA on data, INSERM, but also think tanks and non-profits such as yourselves. So our 4 objectives, are we not ashamed to say that our first objective is to influence, so lobby. We're here to make sure that our host countries know of what we're doing in the UK in science and innovation. And it's to make sure we are, whenever there's something happening, for instance, in France, for instance, last year, the G7, there was a lot of talk on data and AI, is to make sure that we are in the right place at the right time, having the right discussions with the right people. Prosperity, so we support the UK economic growth by bringing together UK and host countries, academics, innovators, business leaders, and policymakers. So these are the people we work with all the time, as well as NGOs and think tanks. Security, and I'll come to that a bit later, but science, as you know, scientific discoveries contribute to solving some of the serious global challenges we face. Climate change. Who here has heard of antimicrobial resistance? 2, 3, okay, 4. Antimicrobial resistance is actually quite a big problem in the health sector, is how our bodies, some people's bodies have developed resistance to antibiotics. So it's one thing, to microbes, which antibiotics are not able to cure anymore. And that's a big problem because it's not just linked to not taking antibiotics anymore, it's everywhere. It's in the food, it's in water, etc. So Ebola, epidemics, energy, oceans, etc. And in development, we support international development goals and matching UK expertise. So for instance, working with agencies at the UN and this, multilateral level. As a science attaché, I'm working for the embassy. Our objective, I don't know if everyone has ever worked in an embassy or been to an embassy, is to support and strengthen the UK-France relationship, which at the moment is, how can I say, changing. And also, so we work bilateral level, but also multilateral. So the G7, France hosted the G7 last year. It's interesting because very often in the media, you will hear of the G7 or G20 and you'll just see people demonstrating and fighting. But actually there are some very serious decisions being taken at those meetings. So in France, there's, I'll go very quickly, there's 2.5 of us, there's me, there's another person and one who spends some of her time in Paris and some of her time elsewhere in Europe. So it's important to know that each country and region has different objectives. So in France, in Europe, because of the UK leaving the European Union at the end of next week, our main objective is influence and making sure the UK is not left out and that we remain a close cooperator. So this is what I've put here. Our objective is to prepare an even stronger SNI relationship between the UK and France and the EU. So what we do on a daily basis, we do all sorts of things. We support the visits of UK ministers. We go and do lunches and cocktails, as you know. We do lots of cocktails, but they're very useful. We report to London, very important on what France is doing. So when President Macron announces the extra 6 billion, how much was it? 6 billion funding from institutional investors. This is something that will interest London. So we do little notes and we just explain what's going on. Relationship building is key to diplomacy. So we need to know the right people. We need to be out all the time, talking, meeting. And we work on things like the UK-France summit, which happens every 18 months to 2 years between the president and the prime minister. Do you know what the knowledge economy is? You've heard of it. It's this idea that we now live in an economy that is based on scientific discovery and innovation. And the more innovation you produce as a country, and the more you support it as a government, the more likely you are to be, how can I say, bigger economically and be taken seriously internationally. So this is what SIN, Science and Innovation, was created in the early 2000s by Tony Blair at the time, because of this particular context. So we science diplomats. So just give you three things that we do. What science diplomacy refers to is research activities can play the role they can play in fostering positive international relations. So when politicians are not able to communicate anymore, scientists are always able to talk to each other. And that's actually very important and crucial. The use of diplomacy to support international science. Sometimes you need diplomacy, you need diplomats, you need embassies to support what scientists are saying at another level. So I'll take the example of the International Panel on Climate Change. And in AI, there's the Global Partnership on AI, which was announced at the G7 and is now going to be taken up and launched as part, in the OECD. This is a team of scientists in Montreal that came up with the idea that we need a panel to control and the impact of AI on society and its ethical use. And also the use of science to influence policy. So, for instance, in Fukushima, when there was the tsunami a few years ago, or in Iran, for instance, when politicians can't make decisions because they don't have the facts, so scientists will come and advise people, politicians, and decision makers of how to influence and how to determine policy. This is very important. In the UK, we have scientists in every minister and departments. You have a scientist, which is called a chief scientific advisor. And you have one for the whole of the government who advises the prime minister, the chief scientific advisor, I think it's called. So science diplomacy, it's a big topic at the moment. The European Union is thinking about having a unit to help it conduct its foreign policy. I mean, I can send this to you later, but science diplomacy is actually very important. In the embassy here in Paris, we sit in the political section, and we sit in a section that focuses on all the very important topics like economics, climate change, transport, energy, Brexit, etc. So I'll just give you some example of impact. That's a very important word if you ever work in the UK or for a UK organization. It's what are you trying to do and what's the impact? Basically, what's the return on investment? One of the big things we're working on at the moment, as well as the EU exit, is the next France summit. So we work with teams in the Élysée and in the French Ministry of Foreign Affairs and with London. And I can't tell you what's going to happen because I don't know, but some of the ideas that we're submitting, a lot of it is based on science and innovation and on data and AI and ethics. At institutional level, so research institutes. So for instance, we supported last year with my team a partnership between DataIA, which is it's a convergence institute. I think it's led by INRIA, and the Alan Turing Institute in London, which is the AI research center for the UK. We also supported the partnership, and that's when I say supported, is making sure things happen, people meet, they come and talk in the embassy. Sometimes we can give them money, sometimes we can't. The other one is on genomics. There's a partnership between INSERM and Genomics England, and that's a partnership that's been going on for a few years. And we're hoping to continue working and announcing more at the summit. Universities, we support all sorts of partnerships. Recently, Oxford University signed an agreement with the Pasteur Institute on research on AMR. Paris Seine University signed an agreement with King's College. There's loads and loads. We don't know all of them, but when we can, we do support them. And this is also very important because you're a non-profit and we do work with non-profits. And actually in the UK, there is a tradition of UK government to come to people like you for advice because we're not experts in UK government. We're generalists and we rely on your expertise and your networks. And then so we also support cooperation at a business level. So loads of corporates or startups that work in this sphere. We'll talk to them, like the big startup association. In France, you have France Digital, which is the one I work with, but there are others. And then what we also do is we fairly regularly organize what we call inward mission to the UK. So we select a few people in France and invite them to go to the UK. And UK people, we come to Paris. So just to conclude, so science and innovation is very important to UK government because it maintains and strengthens the relationship and dialogue and cooperation when things can become difficult. There's 110 of us in 14 countries, and we very much work as a network. So we tend to, like for instance, in 2 weeks, I'm going to Israel to work with my colleagues there to help them. I've given you some examples of what we do. And just to conclude, this is something I was told on my first day at the embassy. A good diplomat is somebody who goes out, meet people, talks to people, and then the question of impact as well is very important. Even though just one thing, the question of impact is something we find very difficult to measure when we're talking about policy work. So that's it. If you're interested, I have some links there. And I would just like to flag that we're doing at the end of February, we're organizing at the embassy a AI ethics hackathon, which we're actually supporting. We're paying UCL in London to organize it. So there will be an event at the British Embassy, and I will let you guys know if you want to come. You're very welcome. With universities from Germany, Slovenia, France, and the UK. And we have some French MPs, possibly some government officials coming. So thank you.
Thank you very much. Thank you very much, Louisa. It's really, I think among us, there are many people who studied in different countries and many people who collaborate with people from completely different countries. And I think what you said, that even if the governments don't talk to each other, scientists can always, researchers can always talk to each other. It's extremely important to maintain this dialogue.
Great. All right. And I think this concludes our meetup, and now we can move towards the bar where some refreshments await us. Let's thank again our speakers, and we'll have a little photo with the speakers.